Welcome again. In my previous demo, I demonstrated how to import the data inside a machine learning classification learner app. In this demo, to select. I would like to explain how to select different models and how to analyze the performance in the case of training and testing. So, apps classification learner. You could observe the steps again here. Go to MATLAB, select apps, then there you can select classification learner. Now select your file. I have my file in this folder. So bupa.csv, notepad is converted into CSV file. From the previous demo, please recall all the steps involved. So data is appropriate, so I'm directly selecting it. As I mentioned, a class label should be response variable should be appropriately specified. Then there is 5 cross validation. I go for assigning 20% of data for testing. So now the data is taken inside and the session can be started. So by default, if you look at the training phase, tree model is selected. So if you want to select other models, then you go to this step. So you have all models, all linear models, tree models, and you select this. There you can find various machine learning models, including optimization algorithms. You can find ensemble classifiers, then neural network classifiers, simple neural network classifiers, and so on. So let me select all ensemble models. Ensemble models, you know what is ensemble model? It is some sort of selecting the best model among the few models taken for training. So once the model is selected, then I can go for train all. So whatever the models I have selected, those models can be trained. As I mentioned already in the previous demo, feature selection can also be done. If you want to leave certain features, so feature selection is possible by going for this correlation analysis based on correlation coefficient and so on. Specific features can be left out, and the remaining features can be used for training. So that feature selection you can do by using feature selection tab. Already I explained. In this demo, I want to use all the features. So 6 out of 6 features are taken for training. Now the training is going on. One Ansible model which is able to deliver 60.9. One is able to deliver 69.2, which is better than if you select SVM models, then you can get around 68. So select all SVMs, then you train all. Now all SVM models are also trained. So the thing is, at one go you can select so many models, machine learning models, and you can check the performance, training performance. That is possible in this classification learner app. So for the particular model, the ensemble model, you can observe scatter plot which will give details about how two features are contributing correct predictions and wrong predictions. Only wrong predictions you can observe. Here only correct predictions you can observe. So with respect to two features, you can observe wrong predictions and correct predictions. Meanwhile, you can also understand how the features are contributing towards classification using scatter plot. Scatter plot is very good visualization tool to have better idea about the role of features towards the classification case. The confusion matrix for training with respect to particular model. You can observe the correct classifications and wrong classifications. Then apart from that, this ROC curve for particular model and so on. So whatever the model you want to observe, for that model you can observe scatter plot, confusion matrix, and ROC curve. And all these plots can be saved using these tabs. Can be saved separately. So that you can observe. Even the results table for the selected model can also be observed, and it can be saved as separate file here. Save a separate file. You have options everywhere here. So that's about training. As I told, you can select one optimization. So select optimizable naive Bayes, last one, then go for train. So this optimizable naive Bayes here, hyperparameters can be selected for optimization. Then obviously, since the optimization is carried out with respect to iterations, it will run for a while. Those results could also be observed. You can save this plot, optimization plot, and it can be used in our work. So here 30 iterations. For 30 iterations, this will run. For small data sets, time taken is less. If the data set is big, then you have to use some GPU machines or machines uh, with the high RAM. So for all the models, as I told, the scatter plot, confusion matrix, then ROC curve, and then for optimization results, you can observe this plot. So feature selection is possible. Then if you use PCA, dimensionality reduction is possible. Then you can use optimizers. For optimizers, you go for appropriate hyperparameters and other options. Then select models. You can train all. You can observe confusion matrix, ROC curve, scatter, plot, parallel coordinates. It will tell you which feature vector is going wrong from the during training. That also you can observe for the particular model. Then for optimization, you can observe the plot. So there here estimated value as well as observed value both can could be plotted, and you can save that. So this is for training. If you want to have idea about the options available here, then here you have the documentation. What is the minimum classification error plot? So if you click this, it will get into documentation. There you can read the content. You can get uh, enough information about different options available in this application. So once it is done, then training is done. Then you can get into testing. Testing. Yeah. Training is about to be done. So here the maximum accuracy is delivered by ensemble method, which delivers 69.2. And then the naive Bayes optimization, which delivers around 65.9. So it is the not the best output training accuracy we get. So once it is done, training is done, then you can generate function of the feature selection and other thing whatever you have done. You can generate a function, or you can export a model. Same model can be exported, and by which you can go for prediction. You can go for prediction. So next thing is the testing. And then since I have assigned data for testing already, I have assigned 20% of data already for testing. So if you want to test the models for some new data, then it is possible. Test data can be imported from new file, and you can check it. If you have test data in the workspace, you can take the data and you can work it out. The thing is, whatever the data you take inside, it should be in the similar format as that of training data. That is one thing. But as far as this demo is concerned, I have assigned 20% of data already. So test data is already available, ready. It is ready for experiment. So I can select particular model, and accordingly I can go for testing, or I can test all. So let me click test all. So the 20% of the data is given for testing, and all methods are tested now. Now, now you have testing accuracy. Same ensemble method which gives the accuracy of 79.7. So for the particular ensemble model, you can have confusion matrix, ROC curve, and if you go to a result table, then you can get training accuracy as well as testing accuracy. Accuracy validation, total cost, accuracy test, total cost. For almost all the models we have taken. If you select almost all the models, then for all the models you will get the data, which can be saved as separate file here. So if you think about the plots and analysis we can do with respect to different models using this classification learner. So whatever the data you require for say writing one paper, research paper, or one thesis, or something like project report, all the data will be available from this classification learner. So this is about testing. This is explain. Explain will give details about which features are very much contributing towards uh, classification accuracy. So we have different methods. One is local shapely, another one is lime, another one is partial difference. So go to this documentation. How to use local shapely explanations. So here there are two predictors, ALKPHOS, then MCV. Based on these two predictors, how these two predictors are contributing to the uh, how different predictors are contributing to the accuracy. That's what you can observe in shapely explanations. Go to this documentation and try to have more idea about this. Similarly, lime is there. Lime also will give the same sort of explanation. So in that way you can make use of these explanations in our work. So that's about learning, training, testing, and explain. So once it is done, how can we use these models to give prediction for the new data? That is very important. You go to learn again, then you generate a function. Now whatever you have selected one model already, for that model this function will be generated. This function will not be generated for each and every model we have experimented. For one model this function will be generated. So it is in the name of train classifier, or I can use some other name, train classifier 1. I can change the name here, function name here. Accordingly I have to save it, train classifier 1. Then the name of this function also should be train classifier 1. So that is important. So I have saved in that way. Anyhow, let me save this, train classifier uh, 2 2. Then save this. So I have to save in the same name, otherwise it will take on its own, because function name and file name of the function should be the same, then only it will be appropriately called. Now this is one thing. So how can I use this function for prediction? So you can check this program, you can understand that. So trained model as a function, trained model can be exported as a function. Then how can I use that? So I read my input here. Already I have exported, I have say I have my function. trained model function. It is train classifier underscore 1 or 2. This I have saved already, so I am calling that again, for which I need to give my training data. So I have my trained classifier here, and validation accuracy will also be available for this case. So I do training here. Once training is done, I go for only 20 rows for testing, and those 20 rows are given for prediction. So in this trained classifier, I have my function called predict function, to which I am giving my test data. So for the test data, my output labels will be printed. Accordingly, relevant scores will also be printed. So what I do here is, I do training, whatever the type of training I do, I convert that as a MATLAB function, and that is saved. So I can call that function, which is to be trained again for the data set. Then I can go for prediction of new data. Because in the classification learner, I can observe confusion matrix, I can observe accuracy, but I cannot observe these predicted values and so on. So if you want to observe those values separately, then you can use command window, you can use your script, and to write a separate program. So if I run this, training will be done as well as testing will be done for the first 20 rows of the data. So you need to select data appropriately for testing, because it has to be a balanced testing data. Here I have selected first 20 rows randomly. It is not going to be a appropriate testing data, or what is that, appropriate, it is not going to be a balanced test data. So training is going on. Since training is going on, it is taking time. As I told you, this is for only one model which I have selected. So I have to select, particular model, for which if I go for generate function, then for that machine learning model, function will be generated. Function will not be generated for all the models. So for this ensemble model, I have generated a function. That is what training is going on now. Then once training is done, then prediction will be carried out. Okay. Yeah. So it is done. Now I can check my predictions in this variable y fit is response variables for the test data. I have given 20 rows, so 20 predictions I get here. So this is by generating a function for the trained model, for the generate functions. Then I have another option which is called the export model. Here model will be exported with all the parameters and so on. So model will be exported with all the parameters. This is also done for only one machine learning model, not for all the models we have experimented. So trained model will be exported to the workspace. So this is what the workspace. So this is what the workspace there. Trained model is available. Trained model is available. So this is the predict function which I can make use of to predict the output for test data, to predict the labels for the test data. So if I go for export model, the complete model will be exported to the workspace with all the trained parameters. So in that case, how can I use this exported model for prediction? So that's what you can observe here. You can observe. So I have exported the model already. So now these three lines are enough. In this case, there is no training needed, because training is already done. Trained model only exported. Now the model is available with the trained parameters. So just I am reading my data. From the data, I select my test data. Now I directly call my predict function. From the model I exported. So the model exported is trained model. Then a dot. This is the function for prediction. For that I am giving my input test data. So for which this labels underscores will be predicted. Since training is not done, it will get executed immediately. That's what you can observe. Y fit and the scores will get displayed immediately, because training is not done yet. So if you generate a function for particular model, then For using that, you can do training again and you can go for prediction. That is one thing. Whatever we do using classification learner, which can be converted into function, and that function can be used in MATLAB window uh, separately. If you want to use trained model with all parameters, then we have export model option. That is what this one, export model option. If you go for export model, then you don't need to do any training. Then just you need to go for testing prediction. As I told you, export model as well as generate function, these two are meant for only one model available here. You have to select other models and appropriately functions should be created, and you can make use of that. That's about making use of generate function and the export model. So I hope I have explained training, testing, and explain using different options for the data set, liver disorder data set. Then I have explained how to go for generate function export model, so that we can go for prediction using command window script separately. So you can also download data sets and you can check with this classification learner. Any queries you can write to me, or you can send a message. Thank you.